Today we are going to learn about mastering indexing for faster database queries. We will explore how to optimize database performance through effective indexing techniques.
Welcome to our video on mastering indexing for faster database queries. Indexing is a crucial component of database management that significantly enhances the speed and efficiency of data retrieval. In this video, we will delve into the types of indexes, how to select the right one for your database, and best practices for implementation. By the end, you'll have the skills to optimize your databases through effective indexing techniques. Indexing in databases functions much like an index in a book. It allows the database system to quickly locate and access the data without having to search every row in a database table every time a database table is accessed. This dramatically speeds up the retrieval of data. For example, consider a library catalog system. Without an index, finding a book would be a cumbersome task. Similarly, in a database, indexing improves query performance by reducing the amount of data that needs to be scanned. It's important to understand that while indexes enhance read operations, they can affect write operations due to the additional overhead of maintaining the index. Therefore, effective indexing involves balancing between read and write performance. There are several types of indexes, each suited for different types of queries and databases. B-tree indexes are the most commonly used and are ideal for range queries, such as between or comma less than. They maintain sorted data and are highly efficient for read-heavy operations. Hash indexes, on the other hand, are optimal for equality queries, like where id equals 5. They work by computing a hash function on the keys and are generally not used for range queries. Bitmap indexes are particularly useful in data warehousing environments where queries involve multiple columns with a limited number of distinct values. They work well for complex queries involving multiple and/or conditions. Choosing the right type of index is crucial for optimizing performance.
Selecting the correct type of index for your database involves understanding your query patterns and the nature of your data. If your application performs a lot of range queries, a B-tree index might be the best choice. For applications with high frequency of equality queries, hash indexes could provide better performance. Additionally, consider the overhead associated with maintaining each type of index, especially in relation to how often your data is updated. Performance considerations should include not only speed but also storage costs and maintenance overhead. A strategic approach to indexing involves a deep understanding of your database's workload, the nature of your queries, and the types of operations you perform most frequently. While indexes can significantly speed up data retrieval, it's crucial not to over-index. Too many indexes can lead to increased storage requirements and slower write operations due to the additional overhead of maintaining these indexes during data modifications. Regular maintenance, such as rebuilding fragmented indexes, can help maintain optimal performance. Understanding the limitations of each index type is also essential. For instance, hash indexes are not suitable for range queries. Additionally, balancing the read and write operations by selectively indexing only the columns that are frequently queried can help optimize performance. Continuous monitoring of index performance is necessary to ensure that the indexes are still beneficial as the database and its usage evolve. Identifying and removing unused or redundant indexes can also help streamline operations.
Analyzing query performance is a critical step in ensuring that your indexes are effectively improving database efficiency. Query execution plans can provide insight into how queries are being executed and whether indexes are being used optimally. Look for signs of bottlenecks, such as full table scans, which could indicate that an index is missing or not being used. Index hints can be used to influence the query optimizer's choice of indexes, though they should be used sparingly as they can complicate query maintenance. Regularly analyzing index usage can help identify whether indexes are serving their intended purpose or if adjustments are needed. Performance tuning involves a continuous cycle of monitoring, analyzing, and refining both the queries and indexes.
Efficient maintenance and updating of indexes are essential for sustaining optimal database performance. Regular maintenance tasks such as rebuilding and reorganizing indexes can help minimize fragmentation and ensure that the index remains effective. Automating index management through scheduled tasks or scripts can alleviate the manual workload and ensure consistency. When handling data modifications, consider the impact on indexes and plan for maintenance windows to update indexes without affecting performance. Ensuring index health involves monitoring for signs of fragmentation, unused indexes, and opportunities for optimization. A proactive approach to index maintenance can prevent performance degradation and extend the lifespan of your database. Let's explore some real-world case studies where effective index optimization led to significant performance improvements. In one scenario, a company faced slow query response times due to a lack of appropriate indexes on their e-commerce database. By analyzing query patterns and implementing a combination of B-tree and Bitmap indexes, they reduced query execution time by over 70%. Another case involved a financial institution that struggled with high storage costs due to excessive indexing. After a comprehensive audit, they consolidated redundant indexes and implemented a more targeted indexing strategy, achieving a 30% reduction in storage use while maintaining performance. These examples illustrate the importance of understanding your database's unique requirements, challenges, and the impact of thoughtful index implementation. Scalable indexing strategies can adapt to growth and changing data patterns, ensuring sustained performance. To effectively monitor index performance, a variety of tools and resources are available that provide insights into how indexes are being utilized. Database monitoring tools like SQL Server Management Studio, Oracle Enterprise Manager, or third-party solutions offer comprehensive performance metrics, including index usage statistics and execution plans. These tools can help identify indexes that are not being used or are causing performance bottlenecks. Automating the monitoring process through alerts and scheduled reports can ensure that potential issues are identified and addressed promptly. Continuous improvement involves not just monitoring but also analyzing trends and making informed decisions to refine your indexing strategy. Leveraging these tools and resources can lead to a more efficient database operation and a proactive approach to index management.
In conclusion, mastering indexing for faster database queries involves understanding the types of indexes available and their appropriate use cases, implementing strategic indexing practices, and continuously monitoring and maintaining indexes. By doing so, you can significantly enhance your database's performance and efficiency. Adapting your indexing strategy to meet the evolving needs of your database ensures sustained optimization and operational success. We encourage you to apply these techniques and insights to your own databases, leveraging the power of effective indexing to achieve faster query performance and improved database efficiency.